Hello, my name is Roman Opata. I am a PhD student at Odessa National Polytechnical University. Today I am going to present a paper that was written in association with George Ostrov. The title of this work, Probabilistic Methods in Computer Simulation of the Formation of Classes of Primes and Estimation of the Constants of the Generalized Artin Hypothesis. Objectives of work: creation of effective methods of structural analysis of classes of prime numbers, obtain estimates for the Artin's constant for a basis greater than 2, develop a generalized theory of Artin's hypothesis. The solution to the Artin problem is important for investigating the relationship between the properties of natural numbers other than 0 and plus or minus 1 and the properties of the classes of primes generated by a recursive mapping based on Fermat's small theorem. Modeling the processes of generating dynamic information about the structure of classes of primes on a given basis. A logarithmic law of the distribution of primes information about the distribution of smooth primes is important than solving the discrete logarithm problem and applying algorithms for solving it in the modern coding theory, modern cryptography. It is known that finding a smooth large number is very difficult. This implies that it is of considerable interest to search for the laws of distribution of primes, not only with respect to the primitive roots, but also to the generating elements of the subgroups of the residue group modulo prime. Artin's hypothesis does not imply such detailed studies. Such takes were not considered at all. In the process of estimating the constant C, A, and I, two important terms were provided. First term, for any I belong from 2 to k, that I is not equal to k squared, the number of non-empty classes of primes tend to infinity. The second term, for any A belongs from 2 to k, that A is not equal to k squared, the number of prime number is a class P for A and I tends to infinity. Dynamic properties of formation of classes of prime numbers in the generalized Artin hypothesis. In accordance with the developed mathematical model for the formation of base classes of primes of the basis of A greater than 1 and the calculated value for the generalized constants C from A and I for I greater or equal than 1 as a result of computer simulation, it was established that the generalized hypothesis is true. The table shows the values of the Artin constant, the relationship between classes, the dynamics of the formation of classes, and its properties of the set of all primes. Actually, the modeling classes P for A and I were created out for many A belongs from 2 to 32 and 53. Numbers A equal 4, 9, 16, 25 as squares of numbers according to Fermat's theorem cannot be primitive roots of P belong to P and accordingly of residue groups modulo P. Result and conclusions. A detailed analysis of the classes of primes is carried out of the foundations of efficient methods for the structural analysis of classes are created. Estimates of the Artin constant for bases greater than 2 are obtained, and statistically validated of the estimates obtained is proved. A generalized theory of Artin's hypothesis has been developed, which its classical version is a very special case. The correction of the developed approach and computational efficiency is provided. It is proved that a new method for modeling the dynamic of the formation of classes of primes and a description of their properties created the basis for constructing more advanced models of pseudo-prime number generators. The development of new methods of information protection in modern cryptography opens a new possibility for constructing models of the nonlinear dynamic system. With this, we come to the end of the presentation. Thanks for watching and listening.